Hi guys, welcome back. Today we are going to learn how to calculate and use the nth term of an arithmetic sequence. We've got three success criteria, and the first one is to find the nth term of a sequence. So an arithmetic sequence is a sequence of numbers that increases or decreases by the same amount from term to term, or number to number. A number in a sequence is called a term. So we want to find the nth term of this sequence. So first of all, find out what it's going up in. So this one's going up in 2's. So that means the nth term starts with 2n. Then find the term that would go before the first term. So this is sometimes called the 0th term, which would be 3. Now that's positive 3, not negative 3. So we put plus 3 on the end of the nth term. So the nth term of this sequence is 2n plus 3. It's going up in 2's, and the number that would go before the first number in the sequence would be positive 3. Here's another example. So we want to find the nth term of this sequence. So this sequence is going up in 4's. So the nth term starts with 4n. Then the term before the first term would be minus 2. So we put minus 2 on the end. So the nth term of this sequence is 4n minus 2. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So to find the nth term of this sequence, well, it's going up in 5's, so the nth term starts with 5n. Then the term before the first term in the sequence would be minus 2, so the nth term is 5n minus 2. Here's another question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So we want to find the nth term of this sequence. So this sequence is going up in 3's. So the nth term starts with 3n. Then if we take 3 off the first term, we get 0. So it'd be 3n plus 0. But we can just write this as 3n. Here's another example. This time the sequence is going down in 5's, so we're taking 5 off each time. So the nth term starts with minus 5n. Then we think about what number would go before the first term in the sequence, and it'd be 20. Now because it's positive 20, we need to put minus 5n plus 20. Now this is sometimes written as 20 minus 5n. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So this sequence is going down in 4's, so the nth term starts with minus 4n, and the term before the first term in the sequence would be 25. So the nth term is minus 4n plus 25. Or it can be written as 25 minus 4n. Or it can be written as 25 minus 4n. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers. There's your amber answers. And there's your red answers. So now we've completed success criteria 1. So now we're going to move on to number 2, and this is to use the nth term to find other terms of a sequence. So we want to find the 20th term of this sequence. Now we could just keep writing the numbers out until we get to the 20th number, but that's quite time consuming, especially if we were asked for maybe the 100th term or the 500th term of the sequence. We don't want to have to write out that many numbers. So instead we find the nth term of the sequence, which is 2n plus 3, and then we substitute 20 into the nth term. So we replace the n with the number that we want to find. So 20 in this case. Now remember, 2n means 2 times n, and then we add 3. So to find the 20th term of the sequence, we do 2 times 20, which is 40, and then we add 3. So the 20th term of the sequence is 43. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So we want to find 100th term of this sequence. So we find the nth term first of all, which is 3n plus 4. So to find the 100th term, we need to do 3 times 100 plus 4. So 3 times 100 is 300, plus 4 is 304. So the 100th term of this sequence is 304. Here's some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers. There's your amber answers. And there's your red answers. So this time we want to find the first 5 terms of the sequence 3n plus 1. So to find the first term of the sequence, we replace n with the number 1. So we do 3 times 1 plus 1. 3 times 1 is 3, plus 1 is 4. So the first term of this sequence would be 4. The second term of the sequence, we replace n with 2. So we do 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7. So the second term of this sequence is 7. To find the third term, we replace n with 3. So we do 3 times 3 plus 1, which is 10. To find the fourth term, we do 3 times 4 plus 1, which is 13. And to find the fifth term of the sequence, we do 3 times 5 and plus 1, which is 16. So the first 5 terms of the sequence 3n plus 1 are 4, 7, 10, 13 and 16. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers, there's your amber answers, and there's your red answers. And now we've completed success criteria 2. So now we're going to move on to number 3, and this is to use the nth term to prove numbers are in a sequence. So this question says, show if the number 125 is in the sequence 4n plus 3. So if 125 is in the sequence 4n plus 3, we can say 4n plus 3 equals 125. And we can solve it, and if it's in the sequence, n will be a whole positive number. So to solve it, we take 3 off both sides. So 4n equals 122. Then we divide both sides by 4. So n equals 30.5. So because n is not a whole number, that means 125 is not in the sequence 4n plus 3. A second way to do this is solving the equation using a function machine. So we write down what we're doing to n, we're timesing it by 4, then adding 3, and we get 125. So we work backwards doing the opposite. So we take away 3, then divide by 4. 125 take away 3 is 122. And 122 divided by 4 is 30.5. Again, because the answer is not a whole number, that is in the sequence 3n minus 5. Here's another example. So this time we want to prove that the number 160 is in the sequence 3n minus 5. So we write it as an equation and we solve it. So we add 5 to both sides. That means 3n equals 165. Then we divide both sides by 3. So n is 55. And because n is a positive whole number, that means 160 is in the sequence 3n minus 5. It tells us that it is the 55th term of the sequence 3n minus 5. The second way to solve it is to use a function machine. So we write down what we're doing to n, we're timesing it by 3, then taking away 5, and we get 160. So we work backwards doing the opposite. 160 plus 5 divided by 3. 160 plus 5 is 165, and divided by 3 is 55. So 160 is the 55th term of the sequence 3n minus 5. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So for this question, If we write it as an equation first, and then we solve it, so we take 12 off both sides, which means we have 3n equals minus 9. Then we divide both sides by 3, so n is minus 3. Now because n is a negative number, this means it cannot be in the sequence. N has to be a positive whole number. Using the second method, we write it as a function machine. So we're timesing n by 3, then adding 12, and we get 3. So we work backwards doing the opposite. 3 take away 12 is minus 9, and minus 9 divided by 3 is minus 3. So because n is a minus number, 3 cannot be in the sequence 3n plus 12. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers, there's your amber answers, there's your red answers, and there's your purple answers. And now we've completed success criteria 3. So now that we've completed the last objective, it's time to end the video. Hope you enjoyed it and hope you find